Test 1, 2, 3, 3, 2, 1, test out. One, two, three, 3, 2, 1, test out. One, two, three, 3, 2, 1, test out. Welcome to Flight Simulation Association. We're glad you've chosen to join us today, and we'll be beginning today's presentation momentarily. Now is a great time to double check your audio and volume settings to make sure that you're ready to go when the session begins in just a few moments. For those who aren't familiar, Flight Simulation Association is a free, community-driven organization designed to help newcomers get started in home flight simulation. We offer guides and resources in a central place so new simmers can more easily make connections with content creators, developers, and even find other simmers in their neighborhood. We don't make simulators or add-ons or hardware. We're not a store. We don't make money off commissions or affiliate sales, but we know the people who do make simulators and add-ons and hardware, and we're working hard to get them to give you fantastic discounts on some of their top products. You can help support that by creating a free account, becoming a FSA First Officer. By doing so, you'll get access to exclusive discounts, and you'll have the opportunity to submit questions during today's presentation. As a First Officer, you get access to our guides, to a series of 3 discounts that rotate regularly, and to webinars just like this one. You also have the option to upgrade to a Captain membership for $3 a month or $30 a year. FSA Captains unlock additional website features and have access to all of our discounts. That's more than 30 on many of the top products across flight simulation, including hardware, software, and more. If you're not watching today's presentation on FSA, if you're watching on our YouTube channel, on our Facebook page, or somewhere else, please come on and create a free account. By doing so, you'll be able to submit questions during the presentation, plus you'll unlock 3 discounts just for coming on and creating a free account. To do that, go to flightsimassociation.com/register. Put in some information and you'll be asked to verify your email. When you've verified your email, come back onto the website, click Webinars, and you'll see the link to watch this very presentation directly through the FSA website. And by creating your free account, you'll have the opportunity to submit questions that we'll answer during the course of the session, and of course, you'll unlock those 3 discounts. Plus, you have the option to upgrade to Captain for $3 a month or $30 a year, giving you access to additional perks, even more discounts, and most importantly, helping to support the costs of running the website and delivering webinars just like this one. We're just about to get started. We'll look forward to chatting with you and engaging with you over the next several minutes. Thank you very much for deciding to take part today. Stay with us. We'll be back in just a few moments to get started. Hello, everyone, and welcome back to Flight Simulation Association. My name is Evan. I'm one of the co-founders of the community here, and very excited to be back on with you in webinar form. It has been quite a while since our last one of these. Our last webinar happened back in July before Flight Sim Expo, so lots has happened in the world of FSA since we were back in this hybrid virtual format, and it's good to be able to be talking to you all again and to say hi to some of the FSA captains in the chat a couple of moments ago. We're on today with Phil Hulme, the founder of the AuthentiKit project, talking about a really interesting subject that I think is totally taking off in our world, and that is three-dimensional printing or 3D printing, something we've seen happening a lot more over the past several years as the technology has gotten cheaper, more affordable, and more accessible to people. Now, you may have heard that we started talking about this actually a couple months ago when we had Tony on talking about his 737 build. And in the 737 that, yes, he's built in his garage, believe it or not, he was using a 3D printer to build some of the components for that. Phil is going to take that concept even further today. Phil is primarily a virtual reality simmer, so he loves putting on those goggles and does almost everything in the sim in virtual reality. And what he found is that when you're looking at a certain flight control through those VR goggles, you'd love to be able to put your hands on something and feel the exact same shape that you can see. Of course, we've seen in the past several years now way more commercially available hardware options from Thrustmaster, Turtle Beach, Honeycomb, those types of things. But of course, they can't make the exact flight control that you might be looking at in your VR setup. And that's exactly what Phil is here to talk about. He launched the AuthentiKit project to make that kind of thing easier and is going to be on talking all about how 3D printing has become more affordable, more accessible. And for those of you who hopefully are new to this concept of 3D printing, we're going to be talking a lot about how you can consider getting into it, whether it's the right thing for your setup, and just exactly how it all works. I'm sure you're going to have lots of questions, so let me talk a little bit about how you can send in questions today. First of all, we are live across a whole pile of platforms. The majority of people are probably watching on our website, Flight Simulation Association, but we're also live on Facebook, YouTube, and for the first time as well on Sky Blue Radio. So for the first time, an FSA webinar is being live cast not only via video here on our website, but also on the Sky Blue Radio channel that's available via your internet browser, and people can hear us as well as be able to see us. Now, if you have questions, of course, we can't monitor all those different channels, and so the place to go is on our website, flightsimassociation.com. If you have a free account and you're watching this webinar, you'll be able to ask a question using the feature that's right on that website. And if you're an FSA captain, firstly, a big thank you for the support and for the subscription to help grow our community. As a thank you, you have access to a live chat during today's webinar where you'll be able to fire any questions right at me. I'll take those questions, collect them, and we'll pass those on to Phil, who will answer them as we go. So with that introduction in mind, I'm going to bring Phil on today. Phil, it's been nice chatting with you over the past couple of weeks, getting everything all set to go. Welcome to Flight Simulation Association. Thanks for being here, and how are you doing today, Phil?
Yeah, good. Thanks, Evan. Yeah, I'm
Excellent.
doing just fine.
Happy Black Friday. I know it's not necessarily Thanksgiving for you over in the United Kingdom, but for those of us here in North America, it is. So we apologize for interrupting your holiday shopping deals, and we won't keep you for too long. Phil's battling a little bit of weather, so we're keeping our fingers crossed that the wind and weather doesn't cause any issues. But Phil, we're looking forward to hearing what you have to say about 3D printing and about this project that you've created. So let me allow you to tell us everything you know about 3D printing, and I'll be here watching along with you.
Okay, thanks, Evan, and thanks for the opportunity to present here this evening. I hope it goes okay. You're quite right. I'm hearing a gale out the window here. I'm in the north of England. We've got 60 miles an hour, and I saw the lights flickering about 10 minutes ago, and it's settled. But fingers crossed, we're going to press on with the show.
Very good.
So I've got the usual slide, the kind of who is this guy and is he worth listening to slide. But I thought I'd just kind of kick off with a quick overview of what is this presentation and kind of who is it aimed at. Because it's kind of got a cumbersome title of two parts, sort of two things mashed together. So the first part is very much a beginner's guide to 3D printing. So if you don't know anything about 3D printing or just the vaguest sort of sense, and maybe you've seen one, it's pitched at that kind of level. And also, why is it relevant for flight simulation? And after that, if I've done a good job of it, you might be thinking, hey, this 3D printing seems to have a lot of potential, but then kind of it's just a useful tool, isn't it? And that should lead us on to part two, which is AuthentiKit, because AuthentiKit is a flight simulation system. It's based on 3D printing. And that second part should be of interest to anybody, whether you've got 3D printing experience or not at all. So with that sort of backdrop to what we're talking about today, this is who I am. Yes, I'm a flight simmer myself, but if I'm honest, I'm kind of more of a tinkerer and an inventor than a simmer. I spend a lot more hours kind of designing stuff and messing with the rig and 3D printing things than I do the actual simming. I've got a background in IT and websites. I got into simming in 2016. I was looking for something interesting to do with my new Oculus Rift VR headset. So I picked up a copy of Aerofly FS2 and I was just blown away. I was immediately hooked. So I'm in VR and I still remember that sense of genuine vertigo I felt when you shouldn't really do this, but I opened the door of the Cessna 172 at 3,000 feet and wow. And from that point on, I was on a mission for ever more immersive simming. I remember thinking that I want this to feel so real that I break out into a cold sweat if I make mistakes. So I kind of wanted to be motivated to fly like it was the real thing. So that kind of took me down a path of motion platforms. I spent a bit of time contributing to the X Simulator forum. A couple of years back, I created a G-seat, or my version of one. And that's a thing that generates a G-force sensation in your back as you accelerate, or the seat of your pants if you pull a tight turn. And the designs for that are available on xsimulator.net for anyone who wants to make one. And basically, it was that project that eventually led me to 3D printing, which in turn led me to found AuthentiKit about a year ago. So there's kind of one more about me thing, which is pretty relevant because most people know AuthentiKit as the Spitfire project. So yes, I'm a big Spitfire fan. I think it probably seeped into my blood from an early age, as I had a Spitfire magnetic compass sat on my bookshelf throughout my childhood. And then in 1985, I wrote this game for the Amstrad 64, Spitfire 40 it was called. Went down fairly well in the UK. I don't know about overseas. It first came out for a computer in the UK called the BBC Micro, and I wrote the Amstrad version. So that's me. And let's talk about 3D printing. So this is what I want to cover. As I said, it's really kind of basic stuff. I thought, let's kick off with what's the fuss? Why are people excited about it? And then also, I know people are going to ask some questions. So I'll just kind of, the bar's not going to be too high here for these questions. This is a genuine question I had early on, is can you really just press a button and out comes like a throttle quadrant? So I'll answer that question and hopefully that will encourage people to ask a range of questions later, complicated or straightforward, whatever. And then I'll get into what 3D printing is like, as in how does it work? What's the process of it? How do you make stuff? How does a 3D printer actually work? And then sort of what level of tech is it? And what I mean by that is you might be thinking, is this a thing that just kind of sits on my desk like my HP printer? Or is this some sort of noisy, complicated thing that sits in a workshop and you need a lot of training and a lot of skills to use? So I'll kind of address that question. Another question I think people have is how strong is this stuff? How does it compare to a commercial product? So I'll talk about that. And then as in the introduction, I said I would cover, what are you getting yourself into? If you got your mouse over the buy now button on Amazon at the moment for an Ender 3 and you're just kind of wondering what to get, what are you getting yourself into? What are the complications? And yeah, there are some Black Friday deals going on right now. I realize that. So I'll give you my thoughts at the end. What should you look for in a printer? So let us kick off with, what is the fuss? Why are people excited about it? I think there are two reasons. First, there's kind of the sheer capability of the equipment and its ease of use. Now, I've got a workshop full of tools for drilling, cutting, filing, grinding, you name it. And it used to be the only option we had to make stuff. And although I've got some very moderate skill at it, I would always drill a hole, however carefully, I'd always drill it in just slightly the wrong place. And I just found that really annoying. Now, I virtually never use that stuff now. I've got a 3D printer. I put an SD card in it and I press start print, and it builds me a part with a precision that's around 0.1 millimeters. That's 4/1000ths of an inch. That's number one. Number two, the second thing is this whole sharing thing that we all know and love about the internet. Now, you probably already know, you'll know FlightSim.2 or TO. I don't know how you're meant to say it. It's got a vast amount of Microsoft Flight Simulator shareware, and thousands of people have contributed, airports, scenery, and aircraft. And millions, I'm sure it's millions, have downloaded and benefited from it. And the same thing applies to 3D printing. This little snapshot on the right, that's just a 2-minute search on a thing called thingiverse.com, which is kind of an equivalent for 3D printing. So I just kind of put in, flight simulation controls, and I've got rudder pedals, throttle quadrants, flight sticks, collectives, flaps levers, loads of stuff. And if that didn't float your boat, perhaps this 737 quadrant from a website, 737DIYsim.com. Or if you're more a GA kind of guy, there's a guy called Vince Prince on YouTube who does some fantastic stuff. I think he's got a range of things he calls cadet products. I think this is his cadet yoke. He keeps improving it. This is the latest one, and it's just fantastic stuff. And there's many more like him. Lots of great quality 3D printed products out there. So let's talk about how it works, and let's ask that question. Can you really just hit a button and out pops a flight stick or a throttle quadrant? And the answer is no. No, you can't. But think about what comes in the case and the innards of, say, a honeycomb yoke. It's got a plastic case, it's got a plastic yoke handle, and there'll be other structural parts that will be plastic. And you can 3D print these things. Then there's structural items that are steel or alloy, and some of these you can 3D print. But you aren't realistically going to 3D print a spring or a switch, and you're not going to 3D print a USB interface. But these things, these springs, bearings, and so on, they're usually cheap commodity items that you can just get off Amazon and eBay. The expensive stuff is the engineered and the design parts that people are now sharing, and you can print these things for pennies. So let's talk about how you would make that happen. And for me, this was kind of one of the tricky things just to initially get my head around. Nobody just sort of gave me that A to Z of where does it start and how does it come out the end. There's basically 3 parts to it. So this is the first one. You need some CAD files. So I'm talking just 3D models. You either make them yourself with free tools like Tinkercad, or there's a more complex one called Fusion 360, or you can download files that someone else has made, they've put them on Thingiverse, and they're just ready to 3D print. So now you've got your CAD files. Then you need to slice them. Now what you're doing here is basically creating a file that your printer can read. You've got different printers, they've got different functionality, different features. So you're kind of doing that, but also you're making some decisions. You can choose the strength and the precision that you want. It's not especially difficult. In fact, it's not difficult at all. It's free software. Cure is the most popular slicing software. That's free. It comes bundled with profiles for all the major printers, so you just choose one of those. And if you look at that screenshot in the middle, that's a preview of the AuthentiKit Spitfire flight stick. And it's kind of a slice at sort of 3/4 of the way up. You can see the handle is not solid. It's got a honeycomb mesh in it. So you can choose to make the handle stronger by choosing the infill density. So it's not 100%. This might be 25%, which is actually very strong for a chunky object like this. So these are the kind of decisions you make with the slicing. And when you're done, when you've completed the slice, you get a file that has a .g code suffix. You stick that on an SD card, you pop it in a printer, and you just hit print. Now the consumable for the printer comes in many forms. It's called filament. There's carbon fiber reinforced stuff, carbon fiber reinforced nylon. There's ABS, which the auto industry uses a lot. But most people use a material called PLA, and that's what I use 99% of the time. It's a form of bioplastic. It's derived from plant sugars, and a kilogram of that costs you about $20. And you saw that the objects are not solid, so a kilogram actually goes a long way. Now, so that's kind of process. What I thought you might want to see, not everybody's seen this kind of thing before, is what does the printing process look like? Now, you might be aware that it does things layer by layer. And part of that slicing was to choose the layer height. It's because that's sort of a trade-off between speed and precision. Now, if you choose, one of the high quality profiles of the slicer, you'd probably be doing a layer height of 0.12 millimeters. So it's really quite fine. And that's what I nearly always use. So just to sort of give you a picture about what it looks like as it builds, I've got a short video clip here. I won't speak through it. You can hear a little bit of whirring in the background, so I guess that gives you a sense of how noisy it is. And I'll show you this flight stick being printed. First, at a kind of normal speed, and then it kind of does another one in a sort of slow-mo speed. So I'll just kick off that video now. I still love those slow-mo things. I think they look great. Okay, so that's what is going on. Let me talk a bit more about what level of tech is it. Is it like this printer that just quietly sits on your desk and it just prints stuff and you don't need to know anything about it? Although, having said that, mine's always playing up. Or is it more like the thing on the right? It's sort of noisy, it's heavy, it's expensive, you need a lot of skills, a lot of training, that kind of thing. Now, I would honestly say it is way more to the left-hand side than it is to the right-hand side. I really wouldn't worry about the software slicing side of things. If you can handle a flight simulator, you can handle the Cura slicer. As for operating the 3D printer itself, my own experience was I bought the cheapest one around. It was an Ender 3 by Creality, under $200. And I had this a kind of honeymoon period, which lasted several months. Everything just worked absolutely fine. Great prints coming out. Over time, you do need to give them a little TLC, because over time, you're going to certainly experience some niggles. And I'll talk more about those later on. But again, if you've got the patience to optimize your settings for a flight simulator, I really think that most simmers have the mindset to cope with 3D printing. Now, I talked about noise. That previous video was pretty quiet. I don't think that was an Ender 3, or it might be a tweaked one. My Ender 3 was a bit noisier than that. And strangely, the loudest thing was the electronics that drove the motors. I've got an Ender 6 at the moment, and the loudest thing on that is the fan. And that's kind of a bit louder than a PC fan. So let's talk about strength and durability. Kind of simply, you can have it as strong as you want it. If you want something as strong as a metal alloy, you can choose a carbon fiber reinforced filament or a polycarbonate, as in the jack on the right-hand side there, lifting 529 pounds. I'll include a link in the FSA documentation that kind of goes with this webinar to a page on a website from all3dp.com. It's a great website. It's got tons of resources. They're always reviewing filaments, printers, and that sort of thing. And that photo there of the polycarbonate jack, that's from their 2021 review of filaments. Now, you've got a lot of control yourself, actually, about strength. You can choose the infill. We talked about that before. You saw that the honeycomb thing, you can go up to 100% infill if you want, or a lesser infill, and then kind of the walls. The walls are sort of the outer circles, there's like concentric circles on the outside that have got the honeycomb mesh in the middle. And the more walls you have, the stronger it is. So you can make decisions like that. And yes, you can also choose the filament. Now, I said that most people start with a very common filament called PLA. And I found that perfectly strong for my needs. And it's very easy to print, which is why a lot of people use it. Tensile strength is fine. So I'm talking here like, can you snap it? If you design it right and you print it right, this stuff's very hard to snap. It can yield over time, though. So kind of what I mean there is like if you're making a clamp, something is going to be pressing down and sort of constantly under strain. I've designed a few clamps and I've tested this many times, and it does yield a bit. So you might want to switch to a thing called PETG there. It's a different kind of filament. It's not crazy expensive either. It's the same sort of money, really. It's slightly fiddlier to print, but still very reasonable. The only other thing to say about PLA is that if you leave it in a sunny window on a hot day and it gets very hot, I think the figure is 55 degrees Celsius or 130 Fahrenheit, it can go soft and then you can have trouble. So I kind of keep my stuff away from a sunlit window. PETG would go higher than that, but I still use PLA for almost everything. So yeah, there's a link to filaments, which I will provide for people to check that out. Okay, so that's strength. I've talked about the softening of PLA. So let's talk a bit more about problems. Have a look at the picture on the right there. Anybody who's done a lot of 3D printing will have seen this kind of bad hair day thing. So what happens here, typically you get that when you get a thing called first layer adhesion problems. So stuff is getting printed one layer at a time. So the very first layer, this 0.12 mil, it's being pressed down and it's kind of pressed onto the print bed. And it has to kind of squish. And it has to squish flat, and that makes it stick to the print bed. Now, if you don't get that first layer sort of flat and sticking, then as the nozzle moves up and it tries to print the next layer, the first layer can start to come a little bit loose. And as you do more and more layers and it's still not sort of sticking properly, you get to the point where the first layer just slides out of the way, and then the nozzle's printing in thin air, and you're just squirting string everywhere. So that's a thing that you kind of learn about, and you just learn how to, in fact, it's very linked to this next point, really, because most of the time it is about this next point, which is called bed leveling. Basically, you could have that nozzle just at the right height, and it's just squishing nicely and pressing and adhering to the bed in one corner, but things aren't slightly in sync on the rest, and then the opposite corners, say, has got a bigger gap. So when you try and print something in that corner or print a piece in that corner, it doesn't stick there. So it starts to warp and lift, and then you get that first one. So these are just some of the things that you learn in the early days. And there's procedures to follow, and there's little bits of software just to do that. And there's other things. I'll mention something else on the next slide as well that'll kind of help with that. So those are kind of two things you learn early on.
Phil, let me just ask a question courtesy of
Yeah.
FSA Captain Steve. This is going back to the subject from the previous slide about decay. He asks if painting PLA would increase its resistance to decay.
Resistance to decay. Is he? Yeah, I mean, I'm not so sure about decay is a huge thing. I mean, they talk about these things being biodegradable, but in theory, I think the biodegrading and the decay goes on for, you're talking many years. I don't think painting makes a big deal either way. It might give it a little bit of protection from sunlight, if that's what we're talking about. Yeah, that could help. But it's more probably the heat, I think, than anything like sort of rays, ultraviolet or that sort of thing.
Yeah, so I think the question was around, like you said, the heat issue, which I'm not sure the paint can really help. But he does ask a
Yeah.
follow-up on painting, and he's asking about how PLA and PETG react to painting, and is there a specific kind of paint you think that might work better on one versus another?
Yeah, I haven't. I've got to say, I haven't done a lot of painting myself. I'm, I've spent hours designing and printing stuff, but I don't really have a lot of patience. So This is something for people who don't have a lot of patience. There are a lot of guys in our Discord forum who've done some fantastic painting jobs. They've got like modeling experience and so on, and they've kind of painted these things and done some stenciling and that sort of stuff. So if you wanted to join the Discord forum, and there's a link on the AuthentiKit website, it says community powered at the top, and there's a link in there. We've got 600 or 700 people in there, loads of experience in that area. So I'd suggest sort of going in there.
Perfect. Thank you very much. And Steve, I'm sure will join that. He's been a good supporter of ours, and he's definitely, I think he's part of the X-Crafts team, if I remember correctly. And Steve, you can feel free to correct me in the chat here if I'm selling you out. But I think he's been a good supporter of ours, and I'm sure he'll be interested in be able to follow up on that question. So thank you very much. I've got a few more questions that have come in that I'm going to save for the end, but folks, feel free to keep on sharing those through. And Phil, let you keep going.
Great. Okay. Yeah. And thanks for the question. I'm happy to take sort of one or two throughout, but yeah, and I'll take loads at the end. No problem there. Yeah, I'm not going to do everything here. It's not an in-depth analysis. What I would say is when you choose a printer, choose a popular printer. I talked about an Ender 3. That's a very popular printer, because what happens is you get Facebook groups and Reddit groups around those printers. There's guys with deep knowledge about the things that can go wrong, and you just get loads of help and loads of support from those. So I just sort of picked out 2 or 3 things here that sort of crop up. And I'm also going to link to those in the next slide, where I'm going to make some suggestions about printers. So there's kind of a linkage there. Yeah, layer shifting is a thing that can happen. I've had some problems here. And again, I didn't have it for months. And then later on, if you don't give your printer a little bit of TLC, it's a bit like if you think of the print head on your inkjet printer, there's that little rubber band that kind of slides it back and forth. If that sags a little bit, then when you're moving the print head and it's gone up a layer, it might just catch on a little sort of flaky bit of plastic or something. And if the band which is moving it is a bit sort of soft and it's not sort of pulling it firmly, then the print head doesn't travel as far as it should travel. And then suddenly it's printing everything in just slightly the wrong place. And another way that I had that was that as you move up, you need to move up the full amount each time. Because if you don't move up that full 0.12, then you're definitely going to catch the lower layer because you haven't lifted above it. And then you get the same thing, that you've caught the layer below, and the print starts happening in a different place. So, but again, generally, just you don't tend to get these early on. You have some successes, you learn about your printer, and there's people that can help you if you have any kind of trouble with that. So those sorts of things are, you've got a broken piece when that happens. But there's other things which are a bit more cosmetic. There's a thing called stringing, which is not that sort of bad hair day thing at the top. Stringing is more when you get sort of little flaky bits, like a pullover, and over time you get little balls of flaky fur and so on. You get that sort of thing. You get little sticky out bits of plastic, or a thing called zits, which are just where the surface is not really smooth. And it's just got slight little sort of lumps on the surface there. And there's a calibration process which you can kind of spend as much or as little time as you want, just to sort of get a smooth finish. And again, you kind of learn that, and your printing quality gets better. And then probably the big one, kind of brace yourself for this, is it does take time. It's a time money. You can print this stuff for pennies, but like that Spitfire spade stick, you print that overnight probably. But there's kind of a plus and minus of that. It's still a fantastic thing. You kind of come and have a look at this thing in the morning. It's been printing overnight, and magically just sat there. You got this beautifully engineered piece of equipment that looks like you should have paid serious money for, and it's just sat on your printer, and it's costs you like $1 of filament. So that leads me into this slide, which is kind of the last one on sort of the basics of printing, and we'll talk about AuthentiKit. So, it's Black Friday. I just received an email from Prusa, who I mentioned here. They're doing free shipping, and Creality's probably doing deals. So these are some things that I think are worth thinking about. I've kind of listed them in order of sort of price and complexity. And I put this $sign to the side, just to say, as you go down the list, things get a bit more expensive and a bit more sophisticated and you may or may not need them. So first off, there are printers which are called mini printers. Prusa make a mini printer, and they have a smaller print bed, and they're great for a lot of things, but generally for flight simulation products, you're often printing a panel that has got a kind of larger footprint. So you don't want a mini, really. I kind of early on tried to do the AuthentiKit stuff to fit a mini printer, but I sort of had to give up after a bit. That doesn't mean big money, though. Most printers, even the most basic ones, have got a print bed of like 220 at least. I think the Ender 3, it's 225. So you've got a kind of square-ish bed, 225 by 225. And generally the height is at least the same. So the overall volume is kind of 220, 220, 220. So you'd want to be going for that sort of thing. And that's really not going to rule out pretty much anything you'd want. The other thing that's now very commonplace, and Evan, you talked about how the technology's coming along and the price is low, is a heated bed. So that wasn't quite so popular a few years back, but now you'll get that with almost anything. The heated bed's good because when you press that first layer down, the bed gets heated to like 50 degrees C or 60, and it means that first layer adheres better. And with also the type of bed, a glass bed is now fairly common, and I use a glass bed. That's good. Or there's another thing called PEI, which is a little bit more sophisticated and also very good. What these things do is the first layer, when it's hot, it sticks and it holds the print solid, so you can build it up, and and it might get to 20 centimeters high and it's solid and everything's working fine. And then when the print's finished and the bed cools down, and that bond between the first layer and the bed just sort of eases, and the thing just lifts off without any trouble. That's the ideal. Actually, I find that works for me with my setup. But a heated bed's a definite thing. Now, moving on to things where you sort of step up a little bit, slightly more expensive printers would be auto bed leveling. So I said on the other slide that the bed leveling process is something that you do. You can get a printer that does it automatically. So that makes life easier. I talked about layer shifting, and I had it. I don't hear about this a lot as people saying, hey, this is crucial, but I personally found it. And maybe from an engineer's point of view, I think it's an important thing. I don't know if my mouse is coming through here. Is that mouse coming through, Evan? No, okay. I'm kind of got my mouse over the, maybe it's somewhere else. No. On the picture there of the printer, you can see this kind of crossbar, this gantry thing. It's about 2/3 of the way up. Now that thing lifts up. That's the thing that goes up 0.12 each time, and it lifts up the nozzle. And on the cheaper printers, there's a little thing called a Z screw on the left-hand side, and it rotates and it causes it to lift. Now I just kind of feel that, and when it does that, it's pushing from one side and it's kind of hanging off the other side. I just find that the better ones, which you've got a screw on each side, so both sides are lifting, giving it an even amount of lift, and you've got less chance of sort of friction and a bit of snag. And I had some problems with that, a little bit of friction. Kind of, if you put a drop of machine oil and you give it a bit of TLC, you sort of shouldn't have that. But I think a better printer has dual Z screws. I'd like to see more printers have that, actually. And then stepping up again, not into crazy money, but sort of into the top end of the level that people are probably thinking of for this kind of project, would be what's called a direct drive extruder. So again, looking at that picture, in the middle of that gantry thing, you might be able to make out it's kind of got a fan shape on it. That fan sort of shrouds the print nozzle and out squirts this very fine filament. The filament's pushed out by a motor, which pushes the filament through. Now, the motor is not usually on the cheaper printers right next to it at that point. It's set further away, and you can see a little tube there, and that's called a Bowden tube. And the cheaper printers use this Bowden tube setup. And what tends to happen there is that you're pushing the filament through the tube, and it's got a little bit of wiggle room in the tube. So that sort of means that as you push the filament and then you kind of stop pushing, because like you printed something and you want to go like to the other side of the flight stick, or like the two halves of the spade stick, you don't want to be pouring filament out constantly. There's times you stop and you start. with the sort of flex you get in the tube, you get a little bit more of that filament sort of just oozes out and sort of drips out a bit. And you can kind of calibrate for that. But with a direct drive extruder, you get a lot less of that. So it's more about a really fine quality finish. So that's what that's all about. I've left a gap here because there is another level, but probably very few people watching would go to that, because you get into sort of above the consumer level. You get into the stuff that's sort of semi-commercial or commercial. And generally what you get with that is a full enclosure. These printers don't come with an enclosure generally. So an enclosure, you've got kind of dust protection, but you've also got temperature control. And as you use more complicated filaments, and actually ABS is a little bit prone to this, as you get the cooling of the filament, it gets printed at temperature, like 200 C it's printed at, and then it cools. You get little bits of sort of flexing and warping, and things can peel a bit. And if you can control the temperature, you deal with that a lot better. However, for printing PLA, PETG, that sort of thing, you really don't need it. So those are the things I think are important. I think really only the top 5 are the ones. I've listed at the bottom some popular printers, and again, the website all3dp.com is great, and I'll put a link to that. They constantly review the best 3D printers for budget level. So they've got their kind of 2021. In fact, they do it all through the year. Nearly always the Ender 3, and it's the version 2, is the best at the budget level. I got mine for at £170. You get these, there's probably some Black Friday deal. I've heard of people getting them for $99. Great printer. At the right-hand side is Prusa. There are others, but Prusa's built a really good name for themselves. They've got great after-sales service. It's direct drive, it's dual Z screw. It's got all the stuff at the top. The price kind of, it's up there. It varies a bit. You've got kind of duties and tax and shipping. You're looking at sort of $900. And I have just about an hour ago seen an email from Prusa saying it's free worldwide shipping. So I don't know what difference that makes. But their kind of name, they're kind of, they sell themselves on, like, if you want a printer that just prints and you don't need to learn about printing and you just want it to constantly work, get a Prusa. That's kind of their angle. And we've talked about this in our Discord forum, and generally people agree with it. So I got one. Actually, I don't know if you can see it. I've got it here. It's a kit. I don't know if I'd recommend buying a kit. I bought this thing about 5 months ago, and I spent an afternoon on it, and I'm about a quarter of the way through. So I'll get there. You might just want to buy it fully assembled. It'd be a lot quicker. There's a lot of stuff in the middle, and at the bottom, I've picked one out. I know a couple of people who've got these artillery sidewinders. They like them. All3dp.com rate them. They have direct drive. They've got this dual Z screw. They've got the heated bed. I don't think they've got auto bed leveling. That's kind of not the worst thing. So that's kind of a good option. And that, I don't know if people are going to dash off now and kind of hit the buy button, but that is the 3D printing stuff. So I'll press on here, I guess. Happy to answer more questions there, because now I want to talk about AuthentiKit. So you may be wondering, why is this needed? I've given you links to Thingiverse, and there are a ton of great flight control products that are already available. And the answer is, it depends how much DIY you are interested in doing. Now, we talked about that 737diy.com project. And there's a lot of kind of blogs and websites talking about builds. Another one is m1sims.com. And here's a page from Brian Dressel. He said I could use this photo kind of midway through one of his prints. Now, this isn't just a single throttle, but I thought it was a single product. He's doing a whole kind of instrument panel here, but it still kind of covers all the things that you're going to be doing for most of these projects. Because even if you're 3D printing, you're probably going to be doing some woodwork as well, some metal work, maybe even welding. I've not done any welding, but Some of them do. And then when you've done that, you've cut it to shape, you've made the big pieces. They're still never quite right. You've got to carve them a bit and shape them a bit and file them a bit. Then you've got to do some programming. There's controller board stuff. There's Arduino programming and coding and all that sort of thing. You're definitely going to be soldering a lot of joints, drilling a lot of holes, and then there's the electronics and the testing. And I felt that if this project was going to appeal to a wide base of flight simmers, we couldn't be having any of that. So early on, I made a decision that this project would have no cutting, metalwork, soldering, programming, drilling, any of that workshop stuff. This is stuff for the kitchen, not for the workshop. This is for your kitchen table or your dining room table. And also I figured, just to have the widest appeal, most people do not have a garage where they can set up their cockpit. It goes on a desk, and then sometimes that desk needs to be used. So it needs to come off the desk pretty quick as well if you need to use it for something else. So this was my sort of vision of things. You've got a printer, you've got a press fit or a screw fit assembly process. So it's much more like an Airfix project. In fact, it's not even like an Airfix project. I said I don't have the patience to paint stuff. I don't have the patience to glue Airfix or paint it. I would do like Meccano or Lego technical stuff when I was a kid. And that's my vision for what this is all about. So if that is whetted your appetite, you think this could be for you, here's just a little bit more about how it got started, where it's headed, and where it's kind of up to. How does it work? What does it look like on your desk for simming? What is the build like to put one of these things together? How complicated and so on. And then if you want to do it, how can you get started? So let me tell you how it started. It was back in January 2019. I struck up a conversation with Alex Kasabian of Flying Iron Simulations, and he just said they were going to bring out their Spitfire Mark 9 for the Aerofly FS2. And that was the spark. That's the thing that lit the blue touch paper on this project, because I really wanted to fly a Spitfire in VR. I'd got a Cytec yoke and throttle, but for me, I just didn't cut it. I was craving more immersion. I wanted to reach out in VR. I just wanted to grab hold with my right hand of that flight stick. The Spitfire's got that iconic spade grip. And I wanted a proper throttle lever in my left hand. I didn't want to do this whole cockpit. It's just the main controls that because you're in VR, just the stuff you're going to feel, like the trim wheels, and the stuff that just feels really good as well, like the landing gear. They call it a chassis. And because I'm in VR, I wasn't so interested in the full cockpit and the aesthetics and all that stuff. It was about the touch and the feel. And then the other thing, of course, is this is just for me. I was just building it for myself. So I just went back in making this presentation and looked at the discussion thread I had with Alex in 2019, showing him some of my first designs. And actually, the one on the right, that's not one that I took. That's a photo that Alex took of the spade grip with the brake lever. He was the first person I persuaded to buy a 3D printer. I simply sent him the file, which he printed out, and it came out perfectly. He had never used a 3D printer before. I can't tell you how exciting that was for me. Like, I know we all live, in the internet age, but I mean, I live in the UK, he lives in Australia, and I basically emailed him a flight stick. How can that not be cool? I still think that's fantastic. So that was how it began. I got into CAD and designing. Pretty soon, I was spending hundreds, it must be thousands of hours. So then pretty quickly, I thought this is a massive waste if a lot of people aren't using this, if people aren't getting to share this stuff. I decided I didn't want to start a business. I've run a business for 20 years. I retired from that last week. as it happens, a week yesterday. So I wanted to go with something freeware. And on top of that, I wanted it to be accessible to the widest range of people as possible. So that's why I set myself the challenge of coming up with this assembly system. Find a way to not have soldering, because I hadn't seen it anywhere else before. Find a way not to do any programming, no metal work, no workshop tools. And also, I had this other breakthrough while I was designing, in that I realized that it would be much quicker and easier to design stuff if I created reusable components. And by that, I mean, if you think of that picture a couple of slides ago, there was that lever and there was a slot for it where a magnet went in. So basically, I was trying to build this thing with all of the sensors and the magnets and all of everything all built together at the same time. So every time I made a new one, I had to build it all again and work out where it should go and what the best place was. So I kind of thought, what if I make a reusable component? And this one I came up with is called a mag hole. And this thing would have everything in it in a nice compact unit. It would have the Hall sensor. So you've got, everybody knows that Hall sensors, they're non-friction, they last forever, they don't wear out like the other potentiometer approach. They've got the bearing in it. They've got the friction built in. They've got a way to connect wires without soldering. So if I can come up with that, then all I need to do is design the lever and just attach it to the mag hole with a single screw. And then that made me think, well, hey, what if I give away the design for these mag holes, the source for it all, and all the various other components I've come up with? Because anybody, particularly kind of freeware developers and aircraft developers who've got Blender skills or other kind of CAD skills, they could simply drop these components into the CAD and the designs that they're already familiar with, and they could create authentic replica flight controls without needing to understand any of the engineering or any of the electronics. So one of the things I'm doing now is I'm creating a series of SDK type resources with downloads that you can drop into, say, Blender or other products, design standards, and just things for people to follow. So they really just need to design the lever. So that kind of gives you a hint of where this is going, because it's going, I hope, everywhere. You know that we've got a fairly comprehensive set of controls for the Spitfire. I was talking just this week to a lead developer at Just Flight about doing controls for their Hawk. We're talking with Eagle Dynamics. We're working on a Mosquito fighter bomber set of controls. We've got a great collaboration with Aeroplane Heaven. That was the Spitfire Mark 1A. We're making good progress on the Mustang P-51. And it's not just about warbirds. I've made great progress on a set of controls for Robin DR400. In fact, some of that stuff's behind me here. And I'd love to have a set of controls for, well, yeah, basically, let me put it this way. The vision is, if there is a vintage or a classic aircraft that you really love flying, you're not going to build everything for everything, but if there's a few things that you really love flying, then someone somewhere has made an AuthentiKit compatible set of controls that you can download for free, print and assemble in an afternoon at your kitchen table. That is where I want to take it. So let's get down to some of the basics of this, the physical, tangible stuff. So this thing I've called the Universal Hub. It sits on your desk. You'll see the size of it in a second. You get the gist of the size. It's not huge. Like everything else, it's 3D printed. The sockets, they plug in the side. The internal wiring is press fit. This basic version has got an input for 10 controls. You can interchange any flight stick from one aircraft with any other. Same for the quadrant, same for the other controls. I've been looking to keep the cost low at every point possible. So there's a circuit board in this. And the circuit board's about the only thing that costs more than a couple of dollars. And it's still only $30. But most controls have got one inside every control. So in this approach, there's one of these inside the Universal Hub, and you just need one that runs all 10 controls. And that brings down the cost hugely. So in the controls, there aren't electronics, not real electronics. There's no chips or anything. You've just got switches and sensors, kind of the cheap stuff. And then the controls connect on the outside just with standard network cables. So it's standard stuff wherever possible. And as I said, there's no soldering, no programming. It sits on your desk and gives you a sense of the size of it, sorry. It clamps down with a regular monitor stand. Same sort of thing that you'd mount a PC monitor with, something you get off Amazon. You just mount it upside down. And you can see here how that takes things low down, and the cantilevered arm holds the base of the flight stick at a very low pivot point. So then you get that fantastic extra precision that comes from a long stick movement rather than a short joystick movement. And of course, it attaches and detaches very easily. You just got a couple of knobs to turn. And then for the controls, which are on the side of the cockpit, the left or the right, you've got this extra pole that attaches at right angles. You mount the trim wheels, you mount the quadrant, and all the other things that go on the side here. So that's how it looks at your desk. And this is what's involved in assembling it. You get a download you choose what you want, the flight control you want. You get a download. It's got assembly steps. It's got diagrams. You print it yourself, or there's a thing I'll explain in a second a little bit more called community print services. So you can get the printing done by someone else if you don't want to have your own printer initially. I do think it's a good idea to get one later, but you don't need to start with one. Then you've got to source the hardware. All of that stuff, it's commodity stuff from Amazon or eBay. But again, I didn't want that to be an obstacle because there are quite a few bits. So there's a third party called simkitsupplies.com. And they make a box, and for whatever control you want, it's got everything in it just for that box, for that control. And it's cheaper than buying the bits yourself. And then you assemble it. Now, I say in an afternoon. In fact, many of the controls are much less than that. I mean, obviously, I'm used to this. So the Spitfire Quadrant takes me about 45 minutes to assemble. But I sent a kit to a YouTuber called Tactical Pascal, who's a big DCS simmer, and he's got a great channel. And on his video, he tells us it took him an hour and a half to put that Spitfire Quadrant together. So for me, that's kind of the bottom line. That's what success looks like, is that just regular simmers can put this together at their kitchen table. And this story, I just really love this story. It's a great example of it. There was a guy who saw my video about making a flight stick. It was the first one. And he said, I'm a Warbird fan. This is just right up my street. This really strikes the right chord for me. But sadly, I've got two left hands and I don't have time for this. And then on Discord, so that's a comment on YouTube, and it was about a month later, he joined our Discord and he goes, update, I just rebuilt the pitch assembly. So that's the pitch and the roll of the flight sticks. The pitch was a little bit sticky at first. He says, I just rebuilt the pitch assembly and now it flies as smooth as can be. I just buttered the 3-point landing on the first go. Incredible. He's in Belgium, so he promised a Belgian beer to one of the guys who've been particularly helpful to him. That is what I'm looking for, and that has been the success I feel that we've been getting with AuthentiKit for many, many people. And this guy did not have a 3D printer. He used this print service. Somebody printed the parts for him. That's just a photo of a set of parts, plastic parts. He used SimKit supplies. He got a box with all the bits in, and that's his photo of his flight stick, his Spitfire flight stick. So, if you're tempted, this is how you could get started. So do you buy a printer or do you wait? Well, if you don't want to buy a printer first, and it's definitely the cheapest way, pretty much what you pay to buy the parts from somebody, because it's about the time. It's hours and hours to print this stuff. It is cheaper to buy a printer, certainly an Ender 3. But if you don't want to do that initially, you just want to sort of build something and check it out, we've started a thing called the AuthentiKit Community Approved Printer System. It's not a profit thing, it's just an arrangement with simmers and people on Discord who've printed this stuff. They know what they're doing. They're located around the world. They've tested. We've tested them for quality. So they've sent some things, not to me actually, but to a colleague of mine, to kind of show that their print is up to standard and they're calibrating correctly. So there's a kind of a quality step there. They've agreed to print for a fixed low price. So there's no sort of, hey, who are these people and what's it going to cost? There's a fixed published low price, and it's on AuthentiKit's website. And they've said they will print for that price. So there's no uncertainty there, and they'll offer a warranty. So I wanted to set that up just to give people the option of a way of starting without having to get a printer. So that's the thing you can do. I would join the AuthentiKit Discord. I'd suggest that. That's a great source of support. There's also a forum coming soon. Not everybody loves Discord, I know that. So I'm going to set up a forum very soon. You're going to need that monitor stand. Just get that from Amazon. There are links on the AuthentiKit website. There's a slightly different one in the US to Europe, but that's still easy enough thing to get. You'll still want to download the relevant files from AuthentiKit, whether you print the CAD or whether you just need the instructions, because the download includes everything. So get that anyway, and you get the instructions on how to build the throttle quadrant or the flight stick or whatever. And then buy a kit. As I said, I recommend getting it from SimKit Supplies. It's cheaper than getting it yourself. And the reason for that simply is you buy it yourself, and unless you buy 500 screws, you don't get a great deal. So my arrangement with SimKit Supplies was said, okay, I will recommend you, but you need to be selling this stuff a good bit less than people can get it from themselves. So that is a good option for you. And there's a starter kit available. There are certain products, they're called starter kits if you go to SimKit Supplies, and they even include the tools you need. So you don't even need screwdrivers. It includes, there's a little wire stripper you need, there's a magnet you need, Allen keys, they're all in there. So there's, you don't need anything else. And then, assemble it and go fly it. So then you just need to choose what you want. And this is where we're up to at the moment. I've got available now and coming next. We've got the Spitfire Mark 9. That was the first one. We've got the Spitfire Mark 1. Pretty comprehensive set of controls there, including the stick. The latest one I finished was the P40B Tomahawk. We've got the trim wheels for that as well. Stick coming soon for that. Now this is a nice quadrant actually, because it's pretty versatile. I'm looking forward to flying it with the biplane in Microsoft Flight Simulator, the Waco YMF5. It's a pretty good fit for that actually, and the Piper Cub and probably quite a few other GA aircraft. So that's a nice control if you don't just want to be flying a Spitfire. And then coming next, progressing really well, we've got some Mustang P51 controls in development, and my colleague Dennis is doing a great job leading a project for some Mosquito fighter bomber controls, and that's going to be cracking kit that is coming out there. That's very exciting stuff. Time-wise, we're probably pushing it for the end of this year for the Mustang Mosquito stuff, but I think there's a fair chance in January we'll have some of those controls coming out. So if you want to stay on top of where that is and where we're up to and when they're coming out, there's a website, AuthentiKit.org. All of the development stuff, the videos of how to build stuff is on the YouTube channel. Facebook as well gives us progress updates. I really kind of only put the build videos on YouTube. So if you want to know progress, use Facebook, and day-to-day stuff, some Twitter. I think I'm slightly over. So thanks for letting me run on a bit. I don't know if everybody's gone now and they're all off buying printers, but I'm happy to take some questions.
Oh, that was great. Thank you so much, Phil, for being on and for that great presentation. I was just talking to Dennis actually in the background, and we both were just chatting about what a great presentation that was. And I realize it's difficult to just talk to your webcam, but you sound really natural on stream. So huge thank you for doing this. Lots of positive commentary from Steve on our FSA Captain chat. Ralph, a first officer, sent in an email saying fantastic presentation and thanks for being part of this. Steve again saying awesome presentation right now. So I got a couple questions that I'll fire your way if you're ready to
Go for
take
it. Yeah.
those. I'll start with Brom from the chat and a couple comments from him actually. So he's building a sort of do-it-yourself 737, I guess, mini simulator that'll fit on his desk because he loves the airplane. It obviously doesn't fit in his, office, and so he's actually basically editing little parts of the airplane, 3D printing them, and then building that together on his desk, which is kind of neat. So his question is, with respect to the parts, I guess I'll just read this here. Are all parts designed or printed real size, or will you change the size a little bit to make them fit in desk environments? I guess sort of related to what he's doing with the 737.
Real size. Everything is as real size as I can get. I mean, I've compromised a little bit sometimes on kind of the thickness of a quadrant, just because 2 mil of steel is quite a bit stronger than 2 mil of plastic, so you kind of got to beef a few things out there. But with a bit of sort of careful design, I've kept that sort of dimension pretty close, but everything else is real size.
Yep. And I guess you
Eventually,
can. Sorry, go
eventually,
ahead.
I've got some of my first ones were, yeah, I had things that big, and then they were that big. But thanks to Alex at Fly9 Simulations, yeah, I finally got dimensions right.
And let's just talk about for developers. So, I think about Steve, who's on the X-Crafts team, and obviously the Embraer has that very unique sort of V-shaped yoke that I get a lot made fun of
Yeah,
for all the time because that's the airplane I fly, and it's a really cool yoke actually. I
yeah,
appreciate the design of it, but it's certainly something very unique. So, if there was a developer who wanted to work with you as far as being able to build a model that could then eventually be 3D printed, how would they go about doing that, or what? Just talk a little bit about what the process is when you're working with a developer. What information do you need from them to be able to actually create these things?
yeah. It's early days on that. I'm sort of being pushed a little bit because I am getting people saying, "Hey, I want to do this, I want to do that." So I'm slowly trying to do two things at once, which is prepare a set of videos and downloads, which talk people through a sort of a generic assembly so they can see some of the assembly steps. But probably for the initial one, because it kind of helps to have an understanding of how this is going to go together. Um, but my ideal is that the developer can essentially work with what they've already got, because they've got the 3D model already, and it's particularly if it's a developer who's made the aircraft. So it's just a case of working out, how to slot these controls, these mag holes in it, and so on. So probably initially, I'm just going to one-to-one work that out with people, and then I'm going to work out some process for that, and then produce some more materials. But it's I really would like to get to the point where somebody just needs to think about the aesthetics of the shape of the lever, and then they can just look at these kind of SDKs that I've got, and without too much trouble, work out how that's just going to slot on in a pretty standard way to one of these the axis sensor, the mag hole thing. How you are going to put some friction in that, how you're going to put some sort of resistance, so you get a nice amount of resistance. Um, I'll probably work that out with people initially, um, but over time, I'm hoping that can be a sort of standard build process. Thinking about the yoke, quite a few of those older sort of flight sticks have actually got a lot in common with the Spitfire one, in that they're sort of a split thing, aren't they? They don't have a sort of a pivot point at the base which does all of the axes. They sort of tilt forward and back at one level, and then at the up where the yoke is, then they do the pitch that way.
Yep.
So I'm actually thinking that some of the designs I've got for the Spitfire, which we're going to evolve a bit into the Mosquito, which Dennis is leading that project, probably without too much work, are going to transfer again to some of these sort of vintage yokes.
Excellent. Question from Steve as well. Going back to the mounting system, looks relatively simple and straightforward and easy to remove, but what is the rigidity and the stability of it like when it's actually in use?
Yeah, good, good. I mean, they're strong. These things, these monitor stands. They hold heavy monitors, and so that sort of aspect is absolutely fine. You need to sort of the cantilevered arms. They're not usually taking a huge amount of push-pull resistance. So you need to sort of crank them down tight. But once you've done that, it's good. If you buy I don't say like get this monitor stand. Just about any monitor stand that fits a certain specification works. But if you get the cheaper ones, you'll get a bit more wobble. And there is a preferred one. I've got a link to that on the website. Goes under different names in the US versus Europe, but that one is really kind of strong. It's very rigid.
Perfect. One last question off of Facebook. Do you have a method of printing where the large flat surfaces are completely smooth without printing any artifacts?
Depends what you print on. I print on glass, and you sort of make a decision when you print which way up you go, and sometimes you got choices. Sometimes you don't really have choices, but the whatever goes down flat on the bed is often very smooth indeed. You get a little micro dimple, which I don't actually think looks too unsmooth, because of this sort of this surface that helps the first layer stick. And then the top layer is kind of the only other thing. And there's a thing which I haven't done too much of it. It's called ironing. It's a new option. And what that does is when you've printed the top layer, it kind of goes over it again, just slightly smoothing it over as though you're running an iron over it. And people have said that produces a really nice top layer. And then the side layers, they can get really smooth if you've kind of got your printer dialed in.
Question off of our YouTube channel from Nathan. He may have joined a little bit later on, asking for your recommendation on a type of printer in the $500 range. I think we talked about that earlier. If you want to bring up the slide, or you can just share what your recommendation would be with him.
Yeah, that's tricky. I know a few people who've got this Sidewinder, which is about $400. Um, I I haven't used it myself. Um, I'm not quite sure on the 500 to be quite honest. I would go into the Discord channel and chat to there's two ways. The all3dp.com. I'm gonna share that link. These guys are always reviewing it, and they like the Sidewinder in that sort of range. You've got other options. There's a Creality Ender 6, Creality Ender 5, which is in that area. Creality have got a great following. There's people on our Discord who've got those and like them. I haven't used them personally. So you can get that personal sort of, hey guys, what's this like to use if you join our Discord, and you'll find somebody who's pretty much got almost everything at every range.
Yeah, it's amazing how Discord even has just revolutionized our community. But even if you go back to the forum days, there's sort of something for everybody. We've had all these little facets of our community that are together, and they're just these huge resources of knowledge. So I know a lot of people, particularly in our world at Flight Sim Expo, that are not on Discord. And I keep saying, you've got to download the app and get there, because there's
Yeah,
people like you who are just so happy to help, but it does take a little bit of research and finding. So if people aren't on Discord, it's a free app that you can download. We have one for FSA captains, and if you search through almost every major developer now, and lots of freeware groups just like this one have got Discord servers that you can go into. It works on your phone, it works on your computer, and you just sort of say, hey, I have a question, and you'll find somebody who's extremely knowledgeable and able to just actually most of the time tripping over themselves to answer and try and help you out. It's just an amazing resource within our community now.
yeah, it does. It kind of really encourages that community spirit, doesn't it? People are getting help from someone else, and they're willing to share it, and they have these channels, don't they? So if you've got a question about building something, post it in that channel. If you've got a question about what printer to get, post it in that channel. Yeah, it's a great
Yeah.
resource.
One last comment, I think, from Dennis here. This is going back to the discussion of Steve's question around how stable the monitor sort of arm is going to be for people. Dennis just wanted us to mention that that mounting system is the same for all platforms. So I don't know if you wanted to expand on that at all, but I just thought I'd pass on that comment.
Yeah, the idea that you just get that once. Yeah,
Yeah,
absolutely. Um, you whether it's a Spitfire or whether it's maybe this Embraer or some Cub or whatever, that's the mounting system. And what I didn't mention, yes, is we have this sort of quick release plate thing, so you don't have to sort of weld this thing down. It slots in firmly, and then it sort of slots out again, and you just swap it over. And you're not going to get flight controls for all the aircraft you might like and go buy, but if you've got two or three and you just want to swap between them, you can just do that almost as easily as loading up the software in the sim.
Perfect. And just craning over here to look at YouTube, Nathan says, first of all, thanks, and also was just saying some kind words about being at Flight Sim Expo. So thanks, Nathan, for watching, and to all of our FSA captains, first officers, and members from around the world, those listening on Sky Blue Radio, more than 10 different countries on Sky Blue Radio right now. So huge thank you to everyone for participating, and Phil for the very informative presentation. So just remind us one more time before you go, where can people find more information about this stuff if they're looking to find out about it and get involved?
Yeah, AuthentiKit.org. Should we? Is it possible to pull up that slide? Because people sometimes misspell
Yeah,
it.
for sure. I'll share that with everybody. Yes, there it is. And actually, just one final question from Bram, which just got it in under the wire here. Are you thinking about attending FS Weekend in the Netherlands in 2022, assuming COVID kind of clears up and everything else, since that's a little bit closer to your neck of the woods than Flight Sim Expo would be?
Yeah, true, true. Um, we'll see about that. The one I wanted to get to was the Cosford, RAF Cosford in the UK, but that didn't
It's a
happen
great
this year.
show. Yeah.
Yeah, that is a good one. But yeah, I would like to sort of bring this stuff to some shows and show people. Yeah, for sure.
Great. I know Dennis was there at Flight Sim Expo and he was able to show people a little bit anyway what the Spitfire
Yes.
can do. So
Yeah, that was
hopefully
great.
as that event continues to grow and just generally as events kind of come back a little bit, we'll be able to keep on sharing this with the world. Because again, just like everything else when it comes to flight simulation controls and hardware, you really have to sort of be there, see it, put your hands on it to be able to try it. I think that's what the benefit of these events is. And I know the FS Weekend
Yes.
especially, it's huge for this sort of do-it-yourself cockpit building. That's really what that show is about. So this is a great question, Bram, and I hope you get to go in 2022 if nobody else. I've been to
Yeah, I
Cosford a
think
couple times.
I'm being inspired.
Yeah, I've had the
Good
privilege of
suggestion.
going to Cosford a few times, but FS Weekend is one I've been wanting to do, and I think I was planning to go in 2020 or maybe the most recent one anyway that didn't happen because of COVID and
Yeah.
everything else that's going on in the world these days. Well, Phil, thanks again. Really appreciate you being here. Let me do a couple of quick announcements for Flight Sim Association members. If you haven't seen it, we just announced that our next cross-community panel discussion is coming up on December the 18th. So this is definitely one that you want to bookmark and save the date for. Just like our last cross-community panel that happened back in July, we're going to have developers from across the flight simulation community talking this time about Flight Sim add-on development. So what does it take to build add-ons? What are some of the things that new developers like FlightFX have learned? What do people like Xplane and Laminar Research do to try and make it easier for the third-party add-on developers to be able to create the great products that they have? From Orbix's perspective, what's it like to run Orbix Direct in flight simulation stores? And then we even have a content creator, Blue Games, on to kind of talk about what does the end user think. So we've got the whole process of flight sim development from the flight simulator at the outset, developers of scenery like Flightbeam and FlightFX, and ZA simulations, and then what is the actual store process and what does the end user get out of that experience. In addition to the 6 developers that you see on the screen, we're also welcoming developers of all sizes to participate in our live chat. That goes as part of the webinar. So if you're a flight sim developer, reach out to me. Make sure you get access to our FSA Partners Discord so we can get you in on that. And for those of you who want to participate, whether it's here on Flight Sim Association on YouTube, with Chewy on Twitch, or a whole pile of other content creators, please save the date. December 18th at 20 GMT, and that you can also find on our website, flightsimassociation.com/webinars. And then the other piece I should just share as of just this afternoon, Navigraph's 2021 Flight Sim Community Survey is now available. This survey is huge for the flight simulation community. It helps us as well. A lot of the information that you see on our website is come from data in this survey. So you can help by taking the survey. It does take about 20 or 25 minutes, so maybe grab a nice drink, whether that's a coffee or something more adult when you're about to sit down and do this. But it gives great feedback and data for both us at Flight Sim Association to help new people, for developers as they're trying to decide what products they should release in the future, and just interesting stuff like what are the most popular simulators and how do you actually go about getting online with VATSIM and IVAO and stuff like that. So the link is on the screen, surveymonkey.com/r flight sim survey 2021. If you go to FS Elite or if you go to basically anywhere on social media in the next few days, you'll see lots of people spreading the word about this. If you would take just 20, 25 minutes to put together some responses to that survey, it is super appreciated. Almost 25,000 simmers did it last year in 2020. And so again, great detail, great data for us in the community. Please fill out that survey. You'll also find the link sent to you in an email from us in the next couple of days. And that wraps up our presentation today. Again, a huge thank you to Phil, and on behalf of Phil, the co-founder of Flight Sim Association, and myself, Evan, thank you very much for being here. Wish you all a wonderful weekend, and we'll look forward to seeing you in our cross-community panel on December 18th.